Welcoming you to another physics session. Today we are looking at principle of conservation of momentum. The principle states that when two bodies traveling in a straight line collide, the two bodies hit themselves. The momentum before collision is equal to the total momentum after collision, provided there is no external force acting on the colliding body. Momentum, as we know, is a product of mass times velocity. Is a product of mass times velocity. So there are two types of collision: inelastic collision and elastic collision. What the two are, we shall consider next. Stay tuned. Inelastic collision. Inelastic collision is the collision that occurs when the total kinetic energy of the colliding bodies is conserved, that is preserved. Nothing is lost, nothing is added, and the bodies stick together and move with a common velocity of the collision. You can illustrate that before collision, and then after collision. Before collision, we have an object moving in this direction, which has mass m1 and velocity u1. We have another object moving in this direction, m2, having initial velocity u2. So here, total momentum before collision here will be m1u1 plus m2u2. After collision, the two objects will stick together and move together. So we are having m1, m2 moving with a common velocity that we call v. So after collision, the total momentum will be equal to v bracket m1 plus m2. So this is inelastic collision. It is inelastic because the two objects, when they hit each other, they do not bounce back. They stick together and move together. Hence, the total momentum before collision will be equal to total momentum after collision, which is m1u1 plus m2u2 will be equals to v equals m1 plus m2. u1 here is the initial velocity of body 1. u2 is the initial velocity of body 2. While v here is the common velocity of the two bodies when they move together after the collision. Elastic collision. Elastic collision is the collision that occurs when the two bodies rebound after collision and move with different velocity. Hence, the total kinetic energy is not conserved. We can illustrate that before collision and after collision. After collision. Before collision, we have an object M1 moving with initial velocity U1 colliding with another object M2 moving with initial velocity 2. They are moving in the same direction. So total momentum here before collision, total momentum will be equals to N1 U1 plus N2 U2. This is before collision. After collision, the two objects are not united together. M1 moves with a new velocity V1. M2 also moves with a new velocity V2. So total momentum after collision will be M1 V1 plus M2 V2. But in the situation whereby we have after the collision, the two objects rebound in different direction, in opposite direction. We shall look at that. In a situation whereby we have colliding objects moving in opposite direction, objects M1, which is body M1, moving forward, while this one is moving in a counter direction. The initial total momentum of the two objects, putting the direction into consideration, will be M1 U1 plus minus M2 U2. This one that is going towards the left, backward, make it negative. After collision, if both rebound, M1 moving in backward direction, while M2 now moving in forward direction, there's going to be a switch in their momentum as well. This one that was initially negative will be positive here, while this one will be negative. But in a situation whereby both move in this direction, if both move in this direction and after initially both move in the same direction, after collision they now move in different direction. The total momentum after collision will be negative. Momentum after collision will be negative if both move in different direction like this. After the collision, the momentum will be negative. Let's consider examples under that. Example 1 says a body A of mass 6 kg moving with a velocity of 10 meters per second collides with another body B of mass 4 kg moving in the opposite direction with a velocity of 2 meters per second. Calculate the common velocity in the direction of body A after collision. Solution. So we have two bodies, and you have to determine what type of collision is this. From the ending in the direction of body A, it shows that it is inelastic collision. What are we given? We are given M1 to be 6 kilogram, and we are given U1 to be 10 meter per seconds. We are given M2, or we can say MA, since it is body A and then UA. It's better like that. Then MB, mass of body B, that's 4 kilogram, moving in the opposite direction with the velocity of, so UB is 2 meter per second, but because it is in the opposite direction, that's minus. So find common velocity. Since we have to find the common velocity, that's another indication that it is an inelastic collision. So that means MA UA plus MB UB will be equals to V bracket MA plus MB. Our MA, that's 6 kilogram times 10 plus 4 times minus 2 equals to V bracket 6 plus 4. So that is a 60 minus 8 equals to V bracket 10. So you subtract 60 from it, that's a 52 equals to 10V. So make V the subject of formula. V equals 52 divided by 10. That means V equals 5.2 meter per seconds. 5.2 meter per seconds. Considering example 2. A 2 kg mass moving at 8 meter per second collide with another mass of 1 kilogram moving in opposite direction at 5 meter per second. If the 2 kg mass moves at 0.5 meter per second after collision, what is the velocity of the 1 kilogram mass? Solution to that, what are we given? Given M1 to be 2 kilogram and U1 is 8 meter per second. It collides with M2, 1 kilogram, moving in opposite direction, U2, which is 5 meter per second, that's minus 5 meter per second. It is minus because it is in the opposite direction. So that means, and we can see that after collision, if the 2 kg mass moves at 0.5 meter per second after collision, what is the velocity of the 1 kilogram mass? It means they move with different velocity. So the collision is elastic. Where M1U1 plus M2U2 equals to M1V1 plus M2V2. That will be 2 brackets 8 plus 1 bracket minus 5 equals 2 brackets, we are given a V1. Yes, V1 is 0.5 meter per seconds. That's 0.5 plus 1 bracket V2. So we are going to find V2 that we are not given. So that's 16 minus 5 equals to 1.0 plus V2. 11 equals to 1.0 plus V2. So make V2 the subject of formula. Then V2 equals 11 minus 1.0. That's 10 meter per seconds. 10 meter per seconds. Now we are looking at recoil velocity of a gun. Recoil velocity of a gun. When a bullet is shot out of a gun, the person firing the gun experiences a backward impact. The backward force is called recoil force, while the force propelling the bullet out of the gun is called propulsive force. So what we need to know is that the bullet has a mass. Let mass of bullet equals small m, and then propulsive force, propulsive velocity rather of the bullet, let it be small v. Mass of the gun, that one is capital M, and then recoil force, which is recoil velocity of the gun, that's capital V. So according to principle of momentum, that of the bullet, the momentum of the bullet will be equal to the momentum of the bullet will be equal to momentum of gun. That's mv equals to mv. Let's consider example under that. The example says find the velocity of recoil of a gun of mass 5 kg from which a bullet of mass 10 gram is fired at a velocity of 250 meter per seconds. Solution. We are given mass of the gun, capital M. Mass of the gun, M gun, that is 5 kilogram. Mass of bullets, M bullets, that is 10 gram. Convert it to kilogram, we divide by 1000. We divide by 1000, that will give us 0.010. And we have the velocity of bullets, V bullets. Velocity of bullet is 250 meter per second. So you have to find the velocity of the gun, V gun. So where capital V, the subject of formula, V, that is V gun, equals to mv all over mass of the gun. So that is going to be 0.010 times 250 divided by 5 by your calculator. 5 year 1, 5 year 50. That's 2 decimal places. 1, 2. So that will give us 5.0 meter per seconds. 1, 2. So you can check by your calculator. What will that give you? So if we check by our calculator, it is 0.5 meter per seconds. So that's the velocity of the gun, the recoiling velocity of the gun. However, it will be in the opposite direction. Take note of that. It will be in the opposite direction. So if you have an option that have negative sign, then you go for negative sign. That brings us to the end of this session. Coming your way, some other classes. Keep studying, keep learning.